Hello everyone, welcome to Math Extra. Today's topic is on graphing linear inequalities in a Cartesian plane. Suppose we have an example here uh, of an inequality y is less than or equal to x minus 2. So in order for us to graph this into a Cartesian plane, first is that we will change that less than or equal to symbol into equal like this. So y is equal to x minus 2. Next is to set a table for our x and y, and we let x be our independent variable and y be our dependent variable. In making table, you can assume any value or any values for x. But let us see, suppose we have negative 2. So if x is negative 2 from the equation, y is equal to x minus 2. If this is negative 2, then minus 2, that will give us negative 4. So negative 4. Next, if x, for example, is equal to negative 1. So from here, we have negative 1 minus 2, that will give us negative 3, meaning your y is equal to negative 3. Suppose I say that my x is equal to 0, for example. So I have now 0 minus 2, so that will give me negative 2. So y is negative 2. And you can assign, I said, any values for x, but I'll have negative or positive 2, for example. If x is equal to positive 2, that will give me, so 2 minus 2, that will give me 0. So y is 0. And if x is equal to, say, 5, for example. So if that is 5, so x is 5, so minus 2, so 5 minus 2, that will give me 3. So this is now our table showing the values of our x and y, in which we actually formed ordered pairs. The first ordered pair we have is, we have negative 2, negative 4. So that's the first ordered pair, that one. And then we have the second ordered pair, we have negative 1 and negative 3, and so on. So let's plot those ordered pair in a Cartesian plane. Okay, so suppose this is negative 1, negative 2, negative 3, negative 4, and so on. And here we have positive values of y. So we have 1, 2, 3, 4. And to the right of the Cartesian plane are the positive value of our x. So we have 1, 2, 3, 4, 5. And going down, so that's y-axis. So that's the negative values of our y. And so on. Now, our first ordered pair, as what I've said, is negative 2, 4. So we will locate negative 2, 4 in the Cartesian plane. So this is negative 2 here, and the negative 4 is here. So negative 2, 4 is definitely here. Negative 2, 4. Next ordered pair is, we have negative 1, negative 3. So negative 1 is here, negative 3 is here. So the ordered pair or coordinate is there. So that's the ordered pair, negative 1, 3. Next is 0, negative 2. So if x is 0, it's here. And then going down for negative 2. So that's the ordered pair, 0, negative 2. And then the number 4 ordered pair is, we have 2, 0. So x is 2, so 1, 2 is there. And then y is 0, so there. And the last ordered pair we have is, we assume the value of x, which is 5. So this is 5 here. And the value of our y is 3. So going up, 1, 1, 2, 3. So it's here. So we have 5 points actually that we picked. And what we're going to do now is to connect the points. So we will connect the points. Okay, there. So this line actually is now called the boundary line. For boundary line, we have there are two possibilities. We can have solid line like this line that we have, or sometimes we could have like broken line like that. So when are we going to use solid line and broken line? If we have a symbol which is less than or equal to, or greater than or equal to, so less than or equal to and greater than or equal to, so this time we will use solid line. But if it's just like less than and greater than, then we will use broken line. Now, since we have less than or equal to, so we will be using the solid line. And as you can see, this solid line, which is called the boundary line, divided our Cartesian plane into two regions. Let us say, for example, this is the upper region, or maybe you can say left region, and say this side of the boundary line, let's call lower region. Now the question is, which region do you think that contains different ordered pair will satisfy the inequality? So for us to answer that, we need to have a test. So for test, we first test any ordered pair in the upper region. So you pick any ordered pair that belongs to the upper region or to the left side of the boundary line. So let's say this point. Okay, which is actually the origin. Origin belongs to the upper region. So let us say we will be using that ordered pair. So we will use 0, 0. Meaning x is 0, y is 0. And let's go back to the given inequality, y less than or equal to x minus 2. So if x is 0 and y is 0, so y is 0 less than x is 0 minus 2, that will give us 0. 0 minus 2 is negative 2. Is it true that 0 is less than or equal to negative 2? So that is actually false. So meaning that the ordered pair in the upper region or the coordinate in the upper region will not satisfy the given inequality. But before we conclude that it's in the lower, so let's make another test. So let's say second test. We will be picking any number in the lower region. So let us say I'll pick this one. So that is 5, 0. 5, 0 belongs to the lower region. So let's go back to our inequality. We have y is less than or equal to x minus 2. X is 5 minus 2 and our y actually is 0. So 0, 5 minus 2 is 3. So is 0 less than or equal to 3? Yes, that's correct. So this is correct or true. Which means that the region that we are going to shade is actually the region in the lower part, this region here. We will shade that, which means that any ordered pair in this region will satisfy the inequality, including the ordered pair in our boundary because of the less than or equal to symbol. So I think that's all about graphing linear inequality in a Cartesian plane.